With respect to the origin O, the point A has position vector OA equals I plus 5j plus 6k, and the line L has vector equation R equals 4i plus k plus lambda minus I plus 2j plus 3k. Find in degrees the acute angle between the direction of OA and L. All right, so this is the direction of OA and this is the direction of the line L. We're going to find the acute angle between them. So for that, we use the formula cos theta equals dot product of these two directions divided by magnitude of each of these. Magnitude of the first one is going to be 1 square plus 5 square plus 6 square in square root. That would be square root of 62. And magnitude of the second vector is 1 square plus 2 square plus 3 square in a square root, which is 14 square rooted. And now we find the dot product. The dot product would be 1 times minus 1 plus 5 times 2 plus 6 times 3, which would be 27. So now we take cos inverse of this, which gives us theta equals 23.6 after rounding. Part B says find the position vector of the foot of perpendicular of A in L. So A has a coordinate of 156 and the line L has vector equation R equals 401 since J component is 0 plus lambda negative 1, 2, 3. We have to find the position vector of the foot of perpendicular. All right, so let's make a perpendicular like this, and this would be the foot of perpendicular. Let's mark it as X, and we have to find OX then. All right, so what we do, we find the position vector of A, which is 156, then the position vector of OX, which is going to be, just give me a second. 4 minus lambda, 2 lambda, and 1 plus 3 lambda. Because the position vector of OX is going to be the same as this since X lies on this vector line. Okay. Next is finding the expression for vector AX, which will be OX minus OA, which would be 3 minus lambda, 2 lambda minus 5, and minus 5 plus 3 lambda. Now, what we observe is that the dot product of this AX, which we just found, and this direction vector here would be 0 because these are perpendicular to each other. So we find dot product of AX with the direction negative 1, 2, 3. So it's going to be 3 minus lambda, 2 lambda minus 5, and 3 lambda minus 5 dot negative 1, 2, 3 equals 0. Now we multiply these. Negative 1 times 3 minus lambda would be minus 3 plus lambda plus 4 lambda minus 10 plus 9 lambda minus 15 equals 0. Solve this completely and you should get lambda is equals to 2. Now if lambda is equals to 2 and we've been asked to find the position vector of the foot of perpendicular, so we have to find the expression for the vector for OX. So here's OX. We're going to replace the lambda with 2 and that would be our answer. So 4 minus 2 is 2. 2 times 2 is 4. and 1 plus 3 times 2 is 7. So OX would be 2I plus 4J plus 7K. Part C is, hence find the position vector of the reflection of A in L. So what we do now is we have A and coordinates of which are 1, 5, 6. We have the foot of perpendicular, which is 2, 4, 7. And we have to find the reflection of A on this line. Let's call that X, Y, Z. So we're going to use the midpoint formula, which is 1 plus X over 2 equals 2. 5 plus Y over 2 equals 4. And 6 plus Z over 2 equals 7, which gives us X equals 3, Y equals 4. Sorry, Y will not be equals to 4. Y will be equals to 3. And Z will be equals to 14 minus 6, which is 8. So find the position vector of reflection of A in L. This position vector is going to be 3I plus 3J plus 8K.